Hi guys, you're welcome to my channel. Alright, today we're going to discuss about off delay timer. Though I have series of this particular exercise in my channel. If you go to my channel, go down, you see a lot of videos that has this application of DOL, how to use DOL with the off delay timer. Okay, I have a lot of them, but just a recap. Like I told you, I will take you around the design of control systems before I take you direct to automation career. Okay. All right. So I want to recap again to show you once more how to use off delay timer. So this is the subject issue of delay timer. So how to apply this in your DOL circuit or any other equipment you want to control using time sequence or time duration to control. There's also what you call cool down duration. Supposing you want to shut down your generator, particular time will elapse before that particular genset shut down. So you're going to use off delay timer. Advantage of off delay timer is that when off delay timer shut down, it will also knock off any signal, knock off power output. All right. But when you use on delay timer, after shutting down the equipment, the power will still remain on the relay. The relay will still be energized, but the equipment will shut down. But off delay timer will shut down the equipment, it will execute the instruction given to it, also shut down the signal coming to the relay in circuit. Let me repeat again. We have two types of relay to use in this particular shutdown equipment in duration period. If you want to shut down equipment within a specific time, maybe 1 hour time, 5 hours time, for instance, you want to pump water into a storage tank, and before the water get filled up, it will take like 3 hours. And you don't want to wait up to 3 hours before you shut down operation or before you leave the premises. You can put on the pump. While pumping, you can leave the premises. Then after that tank is filled up, within that interval of time, the system will shut down. I just give example. This is just a narrative. It must not be water pumping. It can be any equipment you want to operate within a range of period. So if you don't want to be present while the operation is going on, you want the system to shut down on completion of that particular task. So you can use this relay, this particular relay off delay timer or on delay timer. But the ideal relay that is suitable for that particular function is off delay timer. On delay timer can also be used, but on delay timer, disadvantage of using on delay timer is because is this: when the equipment or when the task is completed, when you executed the task, shutting down after the time elapsed, the relay will still remain energized. That is disadvantage of using on delay timer. It will execute the function. It will actually shut down the operation at that particular time is calibrated to do that. But the power signal to the relay will still remain there. So supposing you are using DC signal for the operation, the battery will still be drawing power. The power to that battery will still be consumed after shutting down, because of the configuration. But if you use off delay timer, after shutting down the operation or after executing the particular task, it will shut down the entire signal coming to that particular relay. Okay. All right. So let me show you how to use off delay timer. Go back to my page, you will see is this particular function and the application. I have more multiple videos explaining that function, and I have their diagrams as well. Okay. You also learn how to do carry out the diagram, how to wire it, and how to also set up the schematic diagram. I have video for them, but I just want to incorporate this to make the video very short. Okay. All right. So this is the schematic. This is conventional schematic diagram for all DOL, and this is the wiring diagram for DOL. Now, our subject of this training now, the subject of this discussion is how to connect off delay timer. So this is the timer. This is the pictorial view of the timer. Okay. I also have the schematic symbol. This is schematic. This is the coil. Then this is the contact. Okay. This is the schematic for DOL. And this is the schematic wiring diagram for the DOL. Now I represent it in schematic, also represent it in wiring diagram. So I want to modify this schematic now, the control circuit. I want to modify it by adding the contact and the coil of the off delay timer. Then I will also incorporate this 3D timer into the wiring. So that's what we're going to do. So just watch me doing that now. So let's start from the schematic. This is my conventional design. So let me apply that now. So what I'm going to do, let's simulate first of all, sorry. Let's simulate this. I put it on. Look at my lamp. Look at this. This one is energized. The contactor is energized. If I want to shut down from here. Okay. Now let's also activate the wiring. I put it on from this button. Sorry, I energize my circuit breaker. I put it on here. Look at my indicator lamp is on. My contactor is closed. I want to shut down, I shut down from here. Watch this one close when I energize. Okay, this is contactor closing. This is my indicator lamp. Now the pump is running, supposing. Okay, if I shut down here, I shut down. This one shut off. Okay, let me change the indicator lamp to green. Let's use green color to signify run. Okay, let's simulate once more. I put on the DOL from here. This one come up. I shut down, it goes off. All right. So now let's now incorporate the timer so that once you put it on, you don't need to shut down again. The timer will execute the task for you. Let's start from the schematic. If you want to incorporate this timer into this place of delay timer, what we're going to do is to cut off the supply to the coil, to the contactor coil, take it off here. All right. Then put the contact here. So it will pass through contact NC before coming here. On this one shutting off, it will now shut down the system. Then you also place the coil of the on delay timer, off delay timer rather. All right, just pay attention, please. This is the coil, this is the contact. So I feed the coil through my lashing branch and also feed the negative positive neutral from here. Okay, within my lashing retainer, within my retainer branch circuit, that is where I feed my timer. So that once this one is closed and here is lash, this one get energized, I will have signal here. This signal will supply this. So once this one elapse, it will cut off. On this one closing, the entire system will shut down. Let's simulate this before we come to wiring of the 3D, okay? To make it faster for you to digest. So let's simulate this now. Let's put the time we want to control. Okay, let's control for, yes, 3 seconds, or let's say 2 seconds. Okay, okay, so now this contactor will shut down after 2 seconds. All right, let's do that now. I put on this, my contactor is energized, this one is shut down. Okay, the time is too fast, let's increase it. Let's say 5 seconds. Okay, all right, let's try more. I put on the system, my pump is there, this one is counting. After 5 seconds, it will shut down. I just shut down. You notice that the entire system shut down. Okay, all right, so now let's now incorporate the timer. Look at the timer. This particular timer that is having this contact, look at it, the actual representation is this. So let's incorporate this into the wiring of this DOL. Remember, the entire wiring here is the same thing I have here. Here is the schematic. Then this is the wiring representation. Okay, all right. So let's do that now. Now the same thing. Remember, I break up a circuit before the coil for me to insert the coil, the contact. Now the same way, look at my coil. This is A1. So I break up this place. Okay, look at joint here. So all you need to do is to, sorry, take it away. All you need to do is to break up here. Before this one coming to coil, I have to feed the off delay timer. Okay, all right. So how do we feed off delay timer? I have my power here. So come to the retainer. This is my retainer. So come to the retainer and feed my off delay timer. Okay. All right. Let me show you the contact so that you choose whichever one you want to use. Go to symbol. Now this is the symbol of the relay. Look at the contact arrangement. 12 is closing with 4. 12 is the common. 12 and 4 is NC. 12 and 8 is NO. Then this other circuit, 11 and 3 is NC. 11 and 7 is NO. Okay, whichever I want to use. But in this one, I want to use 9. I want to use this circuit. I want to use 1 and 3. Okay, I want to use this circuit now. So go back to 3D. Okay, this is 9. Terminal 9. We take power from here. Okay, all right. Now I feed my return to 1. Remember I said I want to use 9 and 1. Okay, all right. This is my 1 and this is 9. That's what I want to use now. Okay, all right. Now pay attention, please. Now let me take you back to the symbol. Okay, take a look at the symbol so that you see the contact arrangement. Now check 13 and 14 are the input to the coil. 13 and 14 are the input to the coil. 14 is the A2, that is neutral. Then 13 is the A1, that is a live conductor terminal, that is supplied to the relay. Okay, so I'm using 13, 14 to energize the relay. Then I'm using 9 and 1, this circuit, to feed my circuit. Okay, so go back to schematic. All right, so look at terminal 14. Come to my neutral. Look at terminal 13. I will feed terminal 13 from my retainer circuit. Okay, my latching circuit. I have it here already. From my common, I feed the coil. All right, so this one is taken. Take a look at this again. From my latching circuit, from this latching circuit, I feed the coil. The same way, look at my latching circuit. This 14, 13 is the latching circuit of this contactor. So I feed the coil of this relay from that latching branch. Okay, all right. The same thing here is what is here. Then here is taken from direct starting button to my coil to my relay contact before feeding the coil. The same way, I want to feed this coil through terminal 1, like the contact I told you about that is coming from 9 and 1. 9 and 1 are normally closed, and I want to use that normally closed. Okay, so let's do that now. I feed my power from latching circuit to 9. I loop it to 13 to feed the coil. So this 9 is close to terminal 1. So when the relay is open, it will now break between 1 and 9. Okay. All right. So let me feed the contactor now. I feed my A1 from here. All right. Okay. So if that is done, let me test now. Let's simulate. Just watch simulation now. Let's simulate. Let's put it on. I put my breaker on. Now watch the contactor close. Then watch this one come on. Okay, and watch the timer timing. After 5 seconds, I'll use 5 seconds because of time. After 5 seconds, this contactor will get de-energized. The entire system will shut down. Okay, all right. So let me change this indicator to red so that you understand, so that you see the indicator very okay. The green is not well illuminating. So let's simulate. I put my MCB on. I energize. Look at it, it's lighting. Look at this one close. Look at timer timing. Yes, it has elapsed. So this one now shut down. The indicator shut down. Okay, this is the run lamp. It has shut down. Contactor is now de-energized. Okay, so let's test once more. I put the system on. This one is energized. This one is on. This one is timing. After 5 seconds, look at it shut down. So this is how to incorporate off delay to your DOL circuit. Okay. All right. Thank you. So I would like you to share to your loved ones, to someone that need it most, student, technician, practicing engineers, any relevant authority that need this particular information, you can send it across to them. All right. Okay. Thank you. Subscribe to my channel if you have not done that already. All right. Thank you.